Regression analysis is a statistical method to study the relationship of different variables. We study a relationship of two variables where the value of one variable is depending on the value of the other. The independent variable is the x-axis and the dependent variable is the y-axis. I have taken this simple example of total cost with quantity produced relationship. So total cost is depending on the total quantity produced, and total quantity produced of course is not depending on how much is the total cost. So this dependency that the value of the total cost will be dependent on the value of quantity produced will be studied through regression analysis. Over a period we will see how the values are increasing or how the change is being caused, and we can so come up with a trend line which can help us projecting for the future. This relationship can be expressed by an equation where y is depending on x because of some other variables, and these other variables are a, the slope, because of which the value of y is increasing, and b, which is an intercept, and b, which is an intercept. This means the value of y will still have b if x is 0. To explain it further, I'm going back to the same example. So in this example, you see here, this is the intercept. Even the value of x is 0, y still have this value. That means the total cost will be at least this portion, and it will further increase because of a. To express this in a very simple example, we will consider that y is the total cost, x is the quantity produced, a is the variable cost per unit, and b is the fixed cost. So even if quantity produced is 0, we will have b, the fixed cost. And if we will produce more quantities, more quantity will be increased because of variable cost per unit. And so we will have a trend projection. Let's take a simple example here. The results of regressing y against x are follows. We have an intercept and slope value. When the value of x is 10, we need to estimate the value of y. We will put these values in an equation, and so here the intercept value is b, the slope value is 1.454. We put the numbers there, we will get the answer of y. That means the y's value will be 20.63 when x value will be 10. Going back to the same example, in my example, if I'll analyze it further, I can find out that this equation exists in this data, that y is equals to 18,783 times x plus a fixed portion of 39,200. We can study the relationship of y and x, and so we can come up with an equation. The relationship between y and x that we will study in CMA exam is a linear regression. Linear means a straight line, which means that we are showing a curve something like this, a complete straight line where y and x are perfectly correlated. Change in x would be causing a change in y. It can be the other way around as well. We may have a different curve like this, which means the value of y is dropping when the value of x increase, but still it's a straight line, and we study it through this linear regression analysis formula. The connection between the two variables, the relationship between the two variables will be studied through correlation coefficient. Over a period of time, we will take the data of x and y we collected and we put that into a formula. Wow, that looks complex, but the good news is that you don't need to memorize it. You just need to know that correlation coefficient is the study of the strength of the relationship between the two variables, and if the value of correlation coefficient is +1, which means it's perfectly positive correlation, this means the value of y will increase with the value of x, and it is showing a straight line. 1 expresses the linearity, positive sign explains the direction, and if it is -1, it is perfectly negative relationship. This means the value of y would drop, but since it is 1, that means it's a straight line. Minus means its relationship is inverse. If it is 0, that means there is no relationship, and trend analysis would not be meaningful. So we cannot use the regression analysis formula to predict the values in the future. Remember that the values beyond 1 are not possible. If I'll make a number line, we may have a value close to 0, -1 or +1. Beyond these two values is not possible. So we will either have a value close to 0 or a value close to 1. So let's look at this question. In regression analysis, which of the following correlation coefficient represents a strongest relationship between independent and dependent variable? This is not possible. This is close to 0, so that's the weakest. The one which is close to 1 is the strongest. So B is close to 1. Although it is negative, but it is the strongest. And that's what the question asks. Minus does not mean that it is weak. So if it is close to 1, then it is strongest. So B is the answer here. Going back to the same chart, if I will take the correlation coefficient value and take a square of this, we call it coefficient of determination. It explains the variability of dependent variable when the independent variable shows some changes. So coefficient of determination measures the percentage change in the dependent variable that is explained by changes in the independent variable. Make sure in your exam you calculate coefficient of determination as a percentage. You take R and square the value, you will get coefficient of determination, and that explains the variability in the dependent variable when independent variable shows some movement. Let's do a question to summarize everything. In order to analyze sales as a function of advertising expense, a sales manager of Smith Company developed a simple regression model. The model included the following equation, which was based on 32 monthly observations of sales and advertising expenses with a related coefficient of determination of 0.9. S is 10,000 plus 2.5a. 10,000 is the intercept, 2.5 is your slope. If Smith Company's advertising expense in the month amounted to $1,000, the related point estimate of sales would be how much? We will put the numbers into the equation. 2.5 times 1000 plus 10,000 will give you 125,000. And this is how we can express the change in sales when the advertising expense is increasing.